on electronics, and the things we're going to discuss on electronics are, most importantly, a diode and transistors. Okay, so you need to know what are diodes and the symbols for these electronic devices. And then transistors, we are going to talk about the two types of transistors, PNP and NPN. Then I'll also talk about a silicon control rectifier, which is another electronic circuit symbol that you need to understand. And then application, because each of those I've put there, the uses of them. And yeah, you have to know how, the symbol. So a junction diode, we call it a junction diode. It's an electronic component that allows currents to flow in one direction. It's an electronic component or device that allows currents to flow in one direction. The symbol for the diode is, you need to do a line, which is a wire, then you need to have this and that, and then the wire must come here, and then it's got this. This is your positive side, which is the anode, and this side is the negative side, which is the cathode. That is the symbol for the junction diode. I'm saying it is used to allow currents to flow in one direction. Then we do have a lot of diodes, different types of diodes. The Zener diodes, junction diodes, tunnel diodes, depends with the use. But a junction diode's purpose is to allow currents to flow in one direction. And the arrow side is the flow of current. Just the way it is sitting, it means that the positive terminal of a diode must be connected to the positive of the supply. Then the negative must always be connected to the negative of the supply when we represent it in the circuit diagram. Alright, it must be done like that, do not swap. Because once we swap, we are putting a diode in a reverse bias. The way it is connected here, it means that this diode is in a forward bias. We call it forward bias. In forward bias, a diode is acting as normally. In forward bias, a diode is allowing currents to flow. In a reverse bias, where you swap, or maybe you do this. This is a positive, and then you connect to negative, and the negative, you connect to positive, negative, positive. You see the way I've done. We have reversed, because current should flow this way now, conventional flow. And this is the negative side, this is the positive. So this one means that a diode is in a reverse bias. In reverse bias, a diode is acting like a short circuit. It's not allowing current to flow. So if there's a light bulb somewhere, that light bulb is not going to switch on, because you have reversed the terminals of the diode. In the theory, they will ask you to define what forward bias is and what is reverse bias. So when a diode is connected in a forward bias, it means that the positive side of a diode is connected to positive side of the battery. The negative side is connected to the negative. Or you can use the words cathode connected to the negative. The anode connected to the positive. It's in a forward bias. And when it's in forward bias, current is flowing. And anything, if it's a light bulb, it will switch on. But when we take a diode and reverse it, there won't be any flow of current. It's blocking current. Because the arrow says that's the direction of current flow. Alright, so two things, though I didn't write forward and reverse bias, yeah, but you have to know them. Because what the examiner does in theory is, in a reverse bias, the cathode is connected to the dash of the supply. You see, in a forward bias of a diode, the cathode is connected to dash of the supply. Positive, negative, what. So, you have to choose the right answer for 2 marks. Clear? A diode is called a semiconductor. I'm going to explain. We call it a semiconductor. Why it is a semiconductor? Because it can sometimes allow the flow of current, sometimes it does not allow. Semi means either way. It can allow or not allow, as the two sketches are showing you there. In the first sketch, it is allowing the flow of current. The second sketch, it's not allowing. So if it's a semiconductor, it means that it's in between, conducting and not conducting. Then how is this diode formed? The diode is formed by the process called doping. Okay? You need to write it somewhere. D-O-P-P, doping. We call it a silicon or a junction diode, semiconductor diode. We do doping, which is a process of combining or fusing together the negative and the positive charges. Fusing the negative and the positive charges of materials. Meaning that you have to look for positive metals or positive charged materials and then combine the positive charged materials with negative charged materials. Then we fuse them together, we mix chemically. So that chemical process of mixing the positive charges and the negative charges and then adding into silicon, they use silicon. So what we do is we take silicon plus negative charges plus positive charges. Okay? These are the charges. And then when I say charges, it means that any metal that is negatively, any material that is negatively charged. What do we understand by a negatively charged material? It's a material with a lot of electrons. And then positive charged material is a material with a lot of what? Positive charges, which are the holes. You remember about the, electron movement. It's from an electron to a hole. A hole is a positive charge. So to make a diode, by schematic representation, we do it this way. A diode has got one side negative, the other side positive. So this is the positive side, this is the negative side of the diode. The in-between point here is called the junction. That's why it is called a junction diode. In between is a junction. So when I say this side is positive, it's this side of a diode. This is the symbol of a diode, but schematic representation, we represent it like that. This is not a symbol. It's just to help you understand like nicely what goes on inside the diode, or how is the diode formed. So on the positive side, we expect to have what? A lot of positive charges, which are the holes. On the negative side, we have what? Electrons. So when a diode is in a forward bias, it means that the junction is narrow. You must understand that. When a diode is in a forward bias, meaning that when it's allowing current to flow, the junction is very narrow in such a way that electrons and the holes will be able to cross the gap nicely, jumping like that. Sometimes the positive charges are attracted this side. So even holes can also move, they can also move. They jump, attraction is here. So if I say this is a reverse bias, it means the depletion layer, we call it junction or the depletion layer. Depletion layer is very wide in reverse bias. When the gap is too much, electrons will cross, few of them will manage to cross to the other side. It's the same as when I was teaching capacitors. Yeah. And then in a forward bias, a junction diode will look like that. Positive charges here, all the positive charges here. And then the gap is too narrow. Can you see the difference? This is forward bias. The gap is narrow. And then electrons will be, freely jumping with high energy. And the junction is effectively, functioning. And that's why current is flowing. More current is flowing because the gap is too narrow. So in case they ask you, what do you understand by reverse bias? You need to explain to us that the negative is connected to negative of the supply, positive to positive. And then that gives us a forward bias in which the depletion layer is what? Narrow. Here the depletion layer is wide. And that's why only fewer electrons will be able to cross that gap, and it gives us what we call a reverse bias, meaning less current, sometimes not even any current will pass, because you are blocking it. Electrons must be passing that way according to the error of the diode. But how can it go that way? It's in a reverse bias, blocked. But we do have another special diode that I must mention to you. Like I said, we have too many diodes. The next one, which is a special diode, is a Zener diode. Z-E, I think it's, yeah. Zener diode. This is a special diode because even in reverse bias, it allows currents to flow. So if in the exam they ask you, which diodes, they'll give you examples of diodes, which one among the given diodes is able to allow current to flow either way. Even I swap the terminals, the Zener diode is going to operate. That is the special diode, Zener diode. But the junction diode only allows currents to flow in one direction. We do have light emitting diode. I think LEDs, you've heard about that. Light emitting diode, LEDs. Which are those ones? Those are diodes that when current passes through them, they emit lights. I think you know, I've got one of them there. It looks like a globe, but it's not a globe, it's a diode. Okay, so with the light emitting diodes, it looks like a junction diode, but it's got arrows like that. The arrows are indicating that light is being emitted when current passes a diode. That's why they say LEDs. So in forward bias, it's going to function. In a reverse bias, it won't, because current won't cross the diode. Then we do have light-dependent diodes. You've heard about them, I don't know. Light-dependent diodes. Those ones, for them to function, they need light. In the dark, they won't allow current to flow. They only operate in the light. That's a special diode also. It's light-dependent diodes. The arrows must be pointing down. Can you see? Because they depend on light to open the gap, to allow current to pass. This diode must be in the light. If it's in the dark, electrons won't pass and it can't function. So they try to put in the dark, then no current. In the light, it needs the light. I think these are the important ones that they discuss with you. There's tunnel diodes, whichever you can. Find time and Google about the diodes. If you look in the book that is on the server, I think there's too much theory or notes on diodes, different types of diodes. Please read through. But the basic ones are the ones I've mentioned to you. But if you want to learn too much, go into the book and read the one on the server. Just go to electronics. They have even explained the graphs, how they operate, characteristics of each of them. Because you need to know. Why I'm teaching you the symbols? Because we are now tomorrow going to start drawing. I might give you a skeleton drawing where there are no symbols. I'll use question papers anyway. And then you must put maybe LED, they remove, they just say light emitting diode. And a junction diode, Zener diode. The symbol for Zener diode, I forgot. Yeah. It looks the same as that, but make sure the line doesn't cross over the diode. Because if you cross here, there is something else. That's a symbol for your Zener diode. That can allow current to flow in all directions. Yeah. And that is my plea. I've said whenever you come, even that time I was not here, look at the symbols so that you know them. Look at the symbols. At least you are lucky because we have drawn them for you and you will have access in the exam. That's the easiest way because you just go and copy and paste. Yeah. Some people are drawing without library. Those that are drawing on the drawing board. You know, the other schools are not using computers, so they must know them by heart. Any questions? Now we need to know, where do we use the diodes? Diodes are used to allow current to flow in one direction. Then diodes are used in rectifier circuits. Diodes are used in rectifier circuits. I think you see here, I've put rectifier circuits. I'll be explaining now what a rectifier circuit is. Diode is also used to convert AC to DC current. Can allow current to flow in one direction, is used in rectifier circuits. Can allow current, is also used to change AC to DC current. Three things. When you want to change your AC to direct current, you must pass through a diode. Current must pass through a diode, then it's converted to DC. So I'm going to do sketches of rectifier circuits, meaning that I must explain how a diode, is used in a rectifier circuit. There are three rectifier circuits. Rectification means changing AC to DC. That is to rectify. When we are inverting, I think you know inverter. To invert. Invert means changing the DC to AC. You know an inverter? Yes. Those that have got solar panels, you need to have a battery and the inverter. Because sunlight will be converted to what? Photoelectric. But that electric is a direct current. So if you need that current in your house, you must change it to AC. Because most appliances in the houses, or in fact all of them, are using AC. So we use an inverter. Inversion is the opposite of rectification. Because to rectify is to change AC to DC. When we invert, we are changing what? Direct current to alternating current. You must know an inverter. Yes. So in a rectifier circuit, we make use of a diode, which is a junction diode. The first one is called a half-wave rectifier. I'm going to draw a sketch of a half-wave rectifier, and then I'm going to draw another sketch of a full-wave rectifier, and the third one is a bridge circuit rectifier. Okay? What we mean by half-wave rectifier is that, I'll clean up here. Half-wave rectifier means that a sine wave looks like that. This is one wave. One wave. So because when we are rectifying, we are dealing with alternating current, which is current with sine waves, you see, like that. So when I say a half-wave rectifier, it's a rectifying system that only uses what? Half of the wave. If current is coming with full waves, only half of its wave will be conducted in the system, in the line, not two waves. When I say full wave rectifier, it means that it's a type of rectifier that's going to conduct both positive and the negative waves. Halves, ne? It's one half and one half. So it's a half and a half making one wave. One half is a positive half, this is the negative half. We know. Because when we go to the graphs, down is what? Negative. Up is what? Positive. So when I say it's a half wave, it's either that we are conducting only one half of the wave into the system, and that one half of the wave is the one we are changing to direct current. Because we are changing the AC to DC. When I come to full wave rectification, it means both waves, both halves will be conducted. And both halves of that wave will be changed to DC. We're getting a point there. Okay. So I'll start with the half wave, where we are saying only this half of the wave is conducted. So if we do a sketch, but this is too big. There is a sine wave. and then I'll just say maybe that wave is conducted. You need to have a transformer, okay? There will be a transformer. This is our transformer, primary and secondary side. Then in this line, you need to have a diode. And if the wave that you are conducting is a positive wave, put the diode on top. You see in this case, I'm conducting the what? Positive wave. So a diode must be on top. If I'm conducting the negative wave, then I must put the diode down here. It's primary and the secondary side. Whatever is happening here is what we learned yesterday, induction. I'm not going back there. It's a transformer here, okay? It's a transformer. And then some examiners want you to draw this sketch. Maybe they'll say put a fuse here. This symbol is a fuse. A fuse has got a line across it. A resistor has no line crossing over it. So don't confuse a fuse and a resistor. So if examiner says on the primary side of a transformer, show what? A fuse. Or show a circuit breaker, which I'll show later. Because a circuit breaker, you need to have a wire and a wire, and then you do that, and then you do a star here, and then you do lines like that. That's the symbol for a circuit breaker. A fuse and a circuit breaker are both used to do what? To regulate the current flow. If it's too high current, it strips. A fuse will melt. You know, a fuse melts. When too much current flows through the line, a fuse will melt. And when it melts, it creates what? A blockage, a short circuit. Current can't cross. But a circuit breaker, if there's too much current, more than the normal current, it trips, it opens up. And then again, it creates a short circuit. No current can cross. So examiner can either ask you to use a fuse or to use a circuit breaker. But you need to know the symbols. So I've just used what? A fuse there. This is the positive side. This is the negative side of the primary side. So we call this one center tap transformer. Transformer with one diode, which is a half wave. They call it a center tap transformer because that is a transformer called center tap. Then there will be a center tap transformer with two diodes, which is a full wave rectifier. Yeah. So this diode here will be changing the AC to DC. Then at that point, you need to put what we call a filter capacitor. Filter capacitor. Yeah. Then this now is DC current that goes to, let me just say positive, negative, positive, negative. Or you can connect this to a load. I'll just put there a load. This load is a DC load. We want to make use of AC current. The AC current that we are changing to DC, there's a reason why we are changing to DC because we need the DC, like car battery. You see, I did a battery there. A car battery needs direct current. It uses DC. So at that load point here, you can either put a battery or just say a DC load. Any machine that requires direct current can be here. Immediately the current crosses the diode, it's changing the AC because here at that point, okay, we have AC power after induction. Then we have AC current. Then when this AC current crosses the diode, it is DC, but there is a little bit of what? AC, but more of DC is here after the diode. That amount of AC current that penetrates through the diode is not required at all to go to the load. You hear me? When current crosses the diode, we need it to be pure DC current because it's going to a DC machine. If on the DC machine there is some current which is AC, that machine won't function properly. If it's a radio, it's going to give you echo, you know, some noise, like that, because we have what we call a ripple. A ripple is when you have two waves mixed together. Two waves, which is a DC wave and the AC wave, must not be together. If a machine is AC, just send AC wave straight to the machine. Immediately you mix with DC wave, you are distorting the wave. And that is called ripple. Okay, R-I-P-P-L-E. We are trying to avoid that one. We call it ripple because it's a distraction of the wave. So what I tell you is that when we say DC plus AC, this wave here is rippled because we have combined waves. And that is when a capacitor comes in. A filter capacitor is there to filter out any AC waves that penetrated the diode. It's filtering out, and then it stores that AC wave here. It stores the AC charges here. The DC charges are the charges that must be sent to the DC load. Then here we have pure DC current going to the load. So that's the system. You need to have a filter capacitor. You need to have one diode being that it's a half-wave rectifier. You need to have a DC wave. And then at the end here, you must show us how is the wave for DC. This is a wave for DC. You do one and you do a line. This is DC output signal. It's not going to be like a sine wave. No, direct current is only on top with a line. That is what you are going to give out after filtration, after the rectification process. You rectify, you do everything to make sure that there is no AC wave that will go to the machine. When I come to a full wave rectifier, I'm going to say both waves will be conducted. So in that rectification process, we are conducting both a positive and a negative half of a sine wave into the system to change to direct current. And then it uses what? 2 diodes. Here it will be center tap transformer with 2 diodes. One diode on top, the other diode here at the bottom. The one at the bottom is in charge of the negative wave, half wave. The one on top is conducting the half, which is the positive half. So we need to now change this same one, but introduce this wave here, your diode here. Please, you must check what I'll do here. This current here must go up to go and connect with that current. Can you see there what I've done? So that this one will be taken back to, that's a bridge, to the transformer. Even the first one was supposed to be, the first one was just direct. But what happens is, in the first sketch, I didn't have a line here, I didn't have a line here, I didn't have a diode here. We just had a line like that. What happens to the stored charge here, which is the AC charge? This capacitor is going to release the charge and send it back to the transformer. This charge that the capacitor stores here will be released down here and back to the transformer and again to be rectified. Can you see? To be rectified further. That is how it should be done. Then, if we say it's now 2-wave rectifier or 2 half-wave, it's going to change now. It will be 2 diodes. 2 diodes is a full-wave rectifier with 2 diodes. Then, the line should not come here. Can you see it's blocking because it's reverse bias? So that's why I'm saying we change this. The current that comes from the capacitor should go this way, like that. The current that is coming under here must have a way up. You can go up here to go and join with that there. So the 2 will combine here. Can you see the arrows? The bottom diode will send its current up there to meet immediately after the first diode also releases the DC wave. Then we combine. This one is more stronger than the single wave rectifier or the half wave rectifier because the output DC is strong, being that we are conducting 2 halves of the wave. Okay, so after that, yes, we are going to have a ripple somewhere there, DC plus AC, but will be filtered by a capacitor, and this filter capacitor will take it back there to be recycled again, to be refiltered again. Then the DC, which is pure DC, will come here to the DC load. So when you measure here, it's the voltage which is DC voltage. And that one will have another wave here. Two of them, direct wave. Those two means that it was a full wave rectifier with two waves, two halves of the wave. Remember the first one I just drew one half. So that one is the DC output using two halves from the AC there. Any questions? Yeah, I came late. I won't finish. I want to explain this. I'll teach this tomorrow. I'll do the bridge circuit lastly because it's rectification as well. So immediately I do a bridge circuit, then we can end there. With a bridge circuit, it's a full wave rectifier again, but it uses what we call a bridge. It uses 4 diodes. 4 diodes. So what we do with a bridge, you are going to have that, which is your AC wave, and both waves will be conducted. Then you are going to have a transformer. Okay? And then this side, you are going to have that. Then there will be a diode here, and there will be a diode here. You must see the direction of the diodes. There will be a diode in this line in a forward bias. 2 diodes must be in forward bias, then the other 2 will be in reverse bias. And then there will be a line here. Okay? Then a capacitor there, and then there's a load here. Four diodes. So this one is more stronger than even the one that is using what? 2 diodes, because its output voltage will be powerful. You must check, guys, what's going on here. When current is conducted, positive, negative, yes, it's coming like that. Induction, there is current coming, current coming. Tell me what happens when current reaches this junction. Is it passing through D1, D2, diode 3, diode 4? At that junction, which one between D1 and D4 will be conducting? D1, because it's in forward bias, correct. So this one comes and brings it out here, fine. Then the bottom current here, the negative current, when it reaches this junction, between D3 and D2, which one is conducting? D2. D2 will conduct, and then they will reunite here. And then we have a strong AC plus DC here. Then the AC will be filtered out into the capacitor. DC will come out here to the DC load. And then we have this result. Then again it continues, the AC back to be filtered. Look at that AC, look at that. Back into that junction. Which one is now functioning? D4 and D3. Can you see? For the retained current, it's going to pass through D3 now, again through D2 out, through D4, D1 out. Then 4 of them will be functioning. So you're going to have a big DC output, strong DC output. So you must do a sketch. Where do we use all these systems? All these rectifier systems are used in what we call battery charging. Okay? The battery charges. Because it's a battery that we need to connect here. That needs what? DC. So there is a question that the examiner likes to ask: draw a battery charger using a bridge circuit, or draw a battery charger using 2 diodes, or one diode. What it's telling you is here, you are going to show positive, negative, positive, negative, positive, negative, and then show the voltage across, which is DC volt. It's a battery. It's going to mention, show a fuse also here. If they want a fuse here, you will put a fuse there, or a circuit breaker. Listen to the question. It guides you. On the secondary side, there is a fuse, or there is a circuit breaker. On the primary side, there is also a fuse. Draw a circuit diagram for this bridge rectifier with a battery charger. 20 marks. 20 marks just to draw this one. I don't think he even wants you to explain. Just a drawing. That's why I said it's electronics. Just a drawing. Yeah. So continue. I was hoping to finish, but I think I came late. Any questions?